As you can see, there we have our Arduino Uno, there we have our sensor, and then it is programmed in a way that it is displaying the values. Now let me show you the values that we are getting. So we have X, Y, and Z. So if I hold it like this, it is in the center. If I move it like this, it is the Y side value changing. So the Y is 306. Now if I bring it here, the Y value change to 338 or something. Now let me zoom out. If I make it go in this end, the Y value goes to the other end, that is 415, and maximum it will go to is 450 or something. Similarly, the X axis is this side. So this is the extreme end for the X side, it is 450, and this is the opposite end of the X side. This side will be 290 or something. See, it will be go maximum to 290. So in between it is variable. So this is the X axis, and Z axis is like this. The opposite side, this is the Z extreme end, you can call it plus Z. Now see 290, it is the other side of the Z axis, this one. See, now this is, you can call like 450 or something. In between this will be variable. So it measures in 3 dimensions. So programming is very simple. First we initialize the serial monitor, then we read the A0 pin, that is ADC 0 for the X axis, ADC 1 for the Y, ADC A2 for the Z axis. Then we just printed them on the serial monitor using these commands. Then I gave a delay to slow down the code to make it readable. Welcome to Learning Microcontrollers. In this video, I will show you how you can interface an Arduino Uno with a 3-axis accelerometer module GY-61 ADXL335. So let's get started. So guys, this over here is our ADXL GY-61 module. As you can see, this is the top view, this is the bottom view. The name of this board is GY-61, while the chip on it is ADXL335. So that's why it is called GY-61 ADXL335 based 3-axis accelerometer. So let's get started. So guys, let me give you some key features. It is based on ADXL335. That chip is a MEMS type accelerometer. It measures 3 axes, X, Y, Z. Now this is important. Analog voltage output for each axis. This means to read this, you will need a microcontroller having ADC pins. So you will need a microcontroller having 3 ADC pins to read 3 of these X, Y, and Z axes. Now this is also important. The operating voltage is 3 to 5 volts. So you can directly interface this or power this up using a 3.3 volt microcontroller or a 5 volt microcontroller. So a range is plus minus 3G, that's decent. And then it's small, lightweight design, and I will also add it is cheap. It is cheap and easily available everywhere. So this over here is our ADXL335 based GY-61 board accelerometer. This is the bottom view. Top pin is the VCC, X, Y, Z, and ground. For the X, Y, Z, you will need ADC pins. And this over here is our Arduino Uno. Arduino Uno have A0, A1, A2, A3, A4, and A5. Total 6 ADC pins. So this over here is our module. I have just rotated it. Now bottom is VCC, then X, Y, Z, and ground like this. Now for the VCC, connected to the 5 volt or the 3.3 volt, whatever you prefer. I will connect it with the 5 volt. For the X, you can use any available ADC pin. I'm going to use the A0. For the Y, A1. For the Z, A2. For the ground, I will connect it to the ground. So this is the simple wiring diagram. So let's get to the hardware before we move on to the programming. So this over here is our hardware. You can see that it is exactly the same as shown in the presentation. This is our module over here, and that is the Arduino Uno. So let's get to the Arduino IDEs to start the programming. So this over here is my Arduino IDE. So let me close the previous codes I was working on. So we start a new sketch, file, click on new. So the new sketch is starting. Okay, the new sketch is on. So this is the sketch. Let me zoom in so you guys can see better. Before you do anything else, press Ctrl S to save your work. Write any name, GY-61. I just write this name, wait. Okay, here you go. I remove these comments. If you want to keep, you can keep them. First of all, we need to read the values coming from the sensor. So we write integer for the X axis. I take a variable called X axis like this. So integer X axis equals to analog read from which channel A0. As shown in the presentation, the sensor is connected to the pin number A0. Then do the same for the Y, change the name of the variable. Another variable will store the value coming from the Y axis, and Y pin is connected to the pin number A1 like this. And now do the same for the Z axis like this. Now change the name of the variable. This will store the values coming from the analog read pin 2 like this. Now as shown in the presentation, I have connected pin number A0 to X axis. A1 to y-axis and A2 to the z-axis. And this analog read is the syntax of the command to read the values from the analog pins of the Arduino Uno. Now guys, we will need to display or do something with this data. So I use a serial monitor to display them as it is to see how the sensor works. So to initial, first of all, we initialize the serial port. I write serial.begin, and the baud rate I set is 9600. You may set any baud rate that you prefer. Then after that, I write here the command to display the values, red values on the serial monitor. So to make it look presentable, I write serial.print. I send a string first. So I call this x-axis equals to. So after that, we display the x-axis. So this will look more presentable instead of displaying the values directly. Then again, just copy paste this. Now instead of print, also add ln. Difference between the print and the println is that this will display on the next line. If you do not use the ln, then it will display, keep on displaying on the same line. So ln means end the line, go to the next line. So it will display here the value, and x-axis, this variable stores the values coming from the sensor. So copy it. I accidentally cut it. So copy paste it here like this. Now do it for the y-axis. Just copy paste this, change the name x to y, and also this variable to y like this. Now do the same for the z-axis. Change it to z like this. This variable as well to the z like this. So x-axis, y-axis, and z-axis, they will be displayed on the screen. Speed of the code will be too fast and it will be difficult to read. So we slow down the speed of the code. For that, I use a delay. 500 will do fine. So after every 500 milliseconds, it will update one reading. I am just slowing down this code to make sure that we can read it easily. If we do not slow it down, then it will be too fast on the serial monitor. So I verify this. Okay, it's fine, no error. I click on upload. Okay, done compiling. It's done compiling, done uploading. That's perfect. Okay, now let me move to the hardware. I set it in a way that you can see both the serial terminal and the hardware. So go to the tools, open the serial monitor. So there you go. So here we are getting the value. See, we have slowed down the code using delay, else it was to be too fast, x, y, and z. So now let's move the gyroscope and see what happens. Okay, let me focus there. Okay, there we have the scope. Okay, I just move it in this way. So once in this position, you can see here the x-axis is 454, 455, 455 or something. If I move it in the opposite, like I move it in that direction, I make it like this. I think you can see it. Okay, now I change its position to the other side. Now the x-axis is 306 or something. If I again move it in the other side like this, again, okay, let me give you more space. Okay, we can have more space like this. This is fine. Okay, in this position, the x-axis is 450 something. See, 450. And if I go in the other side, like if I make it the other way like this, okay, I have to do it like this. Okay, now the x-axis is 451 or something. Okay, here it is 290 something, and if I go in that direction, it's 450. So it is 450 once we are in this end, and in the center it will be in the center. So if I bring it in that direction again, it will be again up to 290 or something. Now if I like place it in the center, just like this, like this. Now this is the center side. Now it is like 370, 360. It will be like center value, because neither we are on the extreme x nor on the minus x. So this can be taken as plus x, like we can call it the extreme end 450, and this can be taken as a negative x, where we get the opposite value. So the x-axis is verified, although it is difficult to move. Now the y-axis is like this. So if we are at this position, it's like 290 something. Now if I move it in that direction, I make it like this, then the y-axis is maximum. So it is like plus y, and this is like minus y. See, this is the extreme for the y, this position, and this is for the other end, like plus y or minus y. So this is how the y-axis will work. So in the center here, if we are neither here nor here, but in the center, it will be like in the center value, like 350. it is the minimum is 290. We can count 290 the minus y and 450 the plus y extreme end, and in the center the whole value will work. Like see, I am here, this is the maximum 290. If I go slowly, it will start to change, see, increase. And once if I go in the opposite like this, it becomes minus, okay, I think you can see it. Okay, now it will be like the opposite end, 450, and if I bring it in this end, it will be 290, and in between it is variable. Now for the z-axis, here the z-axis, this is the z-axis. Now z-axis here is 450, it is extreme end. If I make it opposite like this, now the z-axis is 290, see. So at this point, the z-axis is, you can call it to be at one extreme end plus z, and this you can call to be the minus z, this position. See, it's 290. In between it will be variable. It will have variable value from 290 to 450. So this is how it works. So this over here, this side is our x-axis, this is our y, and then this is the z, either this or the straight side this. So this is how this is gonna work. Although it was difficult for me to move, you can like play with the code. It is easily available, and the hardware is also very simple. You can make it yourself. So guys, this is it. This is it for this lecture. So we'll see you in the next lecture. So goodbye until then.